Welcome to Code Report. I'm your host, Connor Hoekstra. Before we jump into things, I'd like to point out a comment that Bastic Zed made on my Top Coder SRM 732 solution video for problem 1 entitled Deck of Cards. And he pointed out that although the algorithm I provided will pass the full system test that Top Coder provided, it's actually a faulty algorithm. And that's because if you have for a given suit the correct number of cards, but those cards aren't unique, it will pass the system test, but technically that's a test case that breaks the criteria that the problem sets out. So the way you can deal with this is by not only checking the number of cards per suit, but also that each of those values of those cards is unique. So thank you, Bastic Zed, for pointing that out. So that being said, let's take a look at the contest that happened last week.
Last week we had 4 contests: the Top Coder SRM 732 on Thursday evening, the weekly LeetCode contest 78 on Saturday evening. Code Chef's contest, the lunchtime contest, was supposed to happen on Saturday morning, but they were having server difficulties, so they moved that contest to Sunday morning, and then we finished off with the Codeforce's April Fool's contest this morning. Taking a look at the top 10 leaderboards, here they are, and most notably here we have Yui finishing in second place in the LeetCode contest and being beat out by the Stray Cat in first. The problems that I'm going to be covering today in this video are problem 1 from LeetCode contest 78 and problem 3 from the Code Chef March lunchtime contest. And then later on this week, I'll be releasing a couple videos for the HackerRank, our Rank 27 contest that's happening tomorrow, and the third problem from the Top Coder SRM contest that happened last week. So let's take a look at our first problem. The first problem we'll be covering today is problem 1 from LeetCode contest 78 entitled Subdomain Visit Count. The problem states a website domain like discuss.leetcode.com consists of various subdomains. At the top level we have com, at the next level we have leetcode.com, and at the lowest level discuss.leetcode.com. When we visit a domain like discuss.leetcode.com, we also visit the parent domains leetcode.com and com implicitly. Now let's call a count paired domain to be a count representing the number of visits this domain received, followed by a space, then followed by an address. An example of a count paired domain might be 9001 discuss.leetcode.com. We are given a list of CP domains of count paired domains. We would like a list of count paired domains in the same format as the input and in any order that explicitly counts the number of visits to each subdomain. Note that the length of CP domains isn't going to exceed 100, neither will the length of each domain. There's going to be a maximum of 2 periods or dots in each domain, and the value of the count on any domain isn't going to exceed 10 to the power of 5. So let's take a look at one of the examples that LeetCode gave us. So in this example, we have 4 strings: 900 google.mail.com, 50 yahoo.com, 1.intel.mail.com, and 5wiki.org. And so what the question is asking us to do is to look at these counts and then also apply them to not only the domain but the parent domain. So for google.mail.com, we'll have the domain, so that'll get 900, mail.com will also get 900, and com will get 900 as well. And if we have some of the parent domains or the domains themselves showing up in other strings with other counts, we have to add those. So mail.com shows up in intel.mail.com. So at the end of the day, we should see 900 plus 1, which you can see is the output here. So this is a pretty straightforward problem. All it really consists of is parsing. It's not really an algorithm problem. But it gives us an opportunity to demonstrate a couple functions that are useful for converting integers to strings and strings to integers. But the idea is pretty simple. We're just going to take a hash map, and as the key, we're going to store the domain or the parent domain, so that'll be a string, and for the value, we're going to store an integer, which will be the count, and then we just have to do the parsing. So let's take a look at our code. So here we have a function subdomain visits that takes a vector of string as a parameters, our CP domains, and then returns a vector of string, which will be the count paired domains for all of the explicit domains and parent domains. So at the top here, we are going to declare a hash map, our unordered map, where the key is a string and the value is an integer, and we'll call this M. And then we're going to loop through each of our domains in CP domains. And the first thing we'll do is we are going to extract the position of where our space is so that we can split our domain into an integer and the actual domain. So we can use the function stoi, which stands for string to integer, and get the substring and convert that into an integer n. And then for the remainder of the string, we can get one past the index I for the start of our string, and then this just goes to the end, and this will automatically be a string. So then we have our n, which is our count for the domain, and s, which is the string of the domain. And so now what we're going to do is we are going to loop backwards, so starting from the back of the array, and we are going to look for each dot. And as soon as we find a dot, we're going to look to the string that starts to the right of that index, and then get out that substring. And we're going to automatically push this into our hash map using the bracket operators, and then do a plus equals n to the value in that pair that we've extracted from our hash map. And so we're going to do this for, I guess, both of our parent domains. We know we're only going to really find this at most twice. And then at the end, we have to make sure to insert our full domain. So that's just going to be using the string s, and once again, plus equaling the n. And at the end, all we're going to do is convert our hash map into a vector of strings, and we're going to do that by looping through all the elements in our map, our pairs in our map, and then emplacing back. So it's better to use emplace in this situation versus pushback, because we're constructing a string, and we're going to use toString to get our integer, which is the second in our pair, back to a string. So you can use toString to get any integers or other values to a string, put a space in between, and then add the first, which is our domain name. And using this, you will get a correct solution. And the complexity of this is going to be linear in the total length of all of your domain names. The second problem we'll be covering today is problem 3 from the CodeChef March lunchtime contest entitled 3 Integers. The problem states you are given 3 integers a, b, and c. You may perform the following operation an arbitrary number of times. Choose one of the numbers a, b, or c, and either add 1 to it or subtract 1 from it. And the question asks us to find the minimum number of operations required to make the sequence a, b, and c an arithmetic progression. In other words, a sequence which satisfies b minus a and c minus b. And note that t, the number of test cases we're given, is going to be less than 10,000. And the values of a, b, and c are going to be between -10 to the 9 and 10 to the 9. So let's take a look at a couple examples. So the first integer we're given 3. This just represents the number of test cases we're going to get, and then the next 3 lines are going to consist of the values a, b, and c. So if we take a look visually at our first example, you can see that this is already in an arithmetic progression, so we don't need to make any moves. So the difference between b minus a is 5, and c minus b is also 5. So we can just put output for this example. For our second example, -5, 3, and 5, if we look at this visually, we'll note that it's very similar to the first problem, but the only difference being is that b is at location 3, not at location 0. So you can see pretty easily that what we want to do here is move b to the midpoint in between a and c, which is going to be moving it to 0, which will be 3 moves. So that'll be our answer for this problem. And in general, this is going to be what informs our algorithm. We always want to move b to the midpoint of a and c. And that's because it's always cheaper to move just one of these numbers than it is to try and move 2 in order to achieve this arithmetic progression. So the only catch is that for both these examples, the difference between c and a is even. So what do we do if it is odd? So in our third example, -5, 7, and 6, you can see that the difference between c and a is odd. It's 11. So we have 2 different choices. We're going to have to move c to either be 1 to the left or 1 to the right so that we can get an even number, because we need b to be at the midpoint, which it has to be at an integer value. It can't be at 0.5 or 1.5. So what we're going to do is just check. So the first one we can do is move B to 0. So from 7 to 0 is 7, and then we'll move C to the left, and that'll be +1. So the total here will be 8, and this is they both have the same difference. So it's going to be 5 between B and A and C and B. And if we reset this, we can then check the alternative, which is moving B to 1, which is going to be 7 minus 1 is 6 moves, and then C to the right, which is going to be +1. So this will give us 7. So this is going to be our answer because it's the smaller of the two options. And so this is what we'll output. And you might be asking, well, how do we know if we move it to the left or to the right? And the answer is just, you don't need to know. You can just return the minimum of both of these cases. And so that's what our whole algorithm is going to be, checking whether it's even. If it's even, just return the distance between B and the midpoint of these two. And if it's odd, we just check. We just return or calculate both, moving C to the left and C to the right, and then calculating the midpoint based on that and returning the minimum. So let's take a look at our code. So here we have two functions, our main function and a small function, DMP, which stands for distance to midpoint. And so the distance to midpoint just takes three values, A, B, and C. It takes the sum of A and C, divides it by 2, and then subtracts B from it and takes the absolute value. And note that it assumes that A and B when you add them together, you get an even number. And that'll be dealt with in the main function below. So other than the output, which is just reading in T and then looping over T and reading in A, B, and C, we really have a single line of code to solve this problem. So we are using a ternary operator here, which operates on whether A plus C divided by, or modulus 2 is equal to 0. So if A plus C is even, we just return the distance to midpoint using the parameters A, B, and C. If it's not, we go into the other case, and this just returns the minimum of the distance to midpoint passing in A, B, and C plus 1 for one of the calls, and then A, B, and C minus 1. So this is moving C to the right, this is moving C to the left, and then we're adding 1 at the very end to account for this move of the C. And using this, we'll end up with the correct solution. And pretty obviously, the time complexity of this problem is going to be constant. Taking a look at the contests we have next week, it's a very busy week with 6 contests, 7 if you include the tournament put on by Google, the Google Code Jam. So starting off with tomorrow, we have Hacker Rank Hour Rank 27 at 11 a.m. From Code Forces, we have round 473 on Tuesday. Note that I've added a superscript to the Code Forces contests. Some of them are for Division 2 only, and some of them are for Division 1 and 2. So from now on, I'll be adding that. On Wednesday, from Code Forces as well, we also have Educational 41. We've got a 10-day long, I believe, Code Chef challenge starting on Friday called the Long Challenge. We've got the Google Code Jam tournament starting on Friday night as well. Saturday morning, we have Code Forces round 474 for both Division 1 and 2. And of course, finishing off the week, we have the weekly LeetCode Contest 79. And finally, as always, we have our top 10 viewing countries. No movement in the top 6. Ireland and Netherlands swapping spots in 7th and 8th. And Romania dropped 1, and we have a newcomer, Taiwan. So once again, as always, thank you to everybody who is watching all around the world.
As always, if you enjoyed this video, hit that like button. Make sure to follow me on Twitter for reminders 30 minutes before contests start. You can find all of the code that I use in my videos on my GitHub page. All of the links are in the description down below. And finally, if you want to make sure you don't miss any of my upcoming videos, make sure to hit that subscribe button. Thanks for watching, and I'll see you in the next video.